Hi, I'm Syed Mass Online. Today's topic is solution of PDE when one independent variable is involved. In the previous video, we have solved few problems based on the same topic. We'll continue with few more problems in this session. Solve dou square z by dou y square is equals to z given that z is equals to 0 and dou z by dou y is equals to sine of x when the value of y is equals to 0. So we need to solve this. You have only one independent variable, therefore we have to express this in the form of ODE. So express in the form of ODE. Express as ODE. So if we express as ODE, we will be getting d square z by dy square is equals to z. Or if I take z on the left hand side, you will be getting d square z by dy square. This value becomes minus z. Minus z is equals to 0. Now if you write in the form of the operator, it is d square minus of 1 times of z. Taking z common outside, you will be getting d square minus 1 times of z is equals to 0. So if you write down the auxiliary equation, the auxiliary equation will be m square minus 1 is equals to 0. So it is plus or minus 1. So it is 1 minus of 1. So therefore the solution z will be equals to, because it is a homogeneous equation, the complementary function itself will be the solution. So therefore, and also the value of d in this case, the operator is d by dy. So the independent variable is y over here. So the solution should also be in the form of y. So it is c1 e power of 1 times of y plus c2 e power of minus 1 times of y. So that's the value of z you have. So that's the solution. Now to find out the solution of this PDE, you have to replace the C1 by C2 by the function. So therefore, we have the solution of the partial differential equation will be z is equals to. So replace this C1 by the function f of x. I have to replace by f of x because the variable over here is y. Therefore, you have to replace by x. So this will be e power of y plus this is g of x into e power of minus of y, because in the equation even the condition for dou z by dou y is given. So we'll try to differentiate this z, differentiate z partially with respect to y, partially with respect to y. So if I try to differentiate this partially with respect to y, I'll be getting dou z by dou y is equals to. So when I'm differentiating with respect to z, x will be treated as a constant. Now you are differentiating partially with respect to y, so x is a constant. So f of x will be as it is. You have to differentiate e power of y. So e power of y itself, differentiation of e power of y will be e power of y itself plus this function g of x is as it is. Differentiation of e power of minus of y will be e power of minus of y. In minus of 1 you get. Dou z by dou y will be f of x into e power of y. This plus into minus will become minus g of x into e power of minus of y. So you got the value of z. Let me take that as equation number 1. We have got the value of dou z by dou y, that is equation number 2. Now I'll use the conditions. Given the value of z is equals to 0 when the value of y is equals to 0. First condition I'll use in equation number 1. So equation number 1 implies z value is 0, just plug in 0 there, is equals to f of x as it is into e power of y value over here is 0. So just plug in the value of y as 0 plus g of x into, it is e power of, y value is again 0, e power of 0. But we know e power of 0 is 1. Therefore, we get the value as f of x. E power of 0 will be 1. So, we'll just be getting f of x plus g of x. So, let me keep this equation as it is. That equation be equation number 3. We'll go back to equation number 2. So, the conditions that are given to us. So, given dou z by dou y is equals to, you have sine of x and the value of y is given as 0. So, just plug in this back in equation number 2. So, equation 2 will imply. So, we have sine of x is equals to f of x value as it is into e power of y value is 0 minus g of x into, it is e power of y value is 0. So rewriting this one, it is sine of x will be equals to, since e power of 0 is 1, you are left out only with f of x minus g of x. So let me take this as equation number 4. So you have to solve this equation 3 and 4 to get the values of f of x and g of x. So let us try to solve this one. Solve equations 3 and 4. Solve equations 3 and 4. So if you solve equation 3 and 4, you have 0 is equals to f of x plus g of x. Then you have over here, it is sine of x is equals to f of x minus of g of x. So you can see that positive g of x and negative g of x will cancel out. You'll just be left out with sine of x is equals to f of x plus f of x will be 2 times of f of x. I want the value of f of x. So therefore just send this 2 on the other side. So it becomes sine of x divided by 2. So you got f of x solving equation 3 and 4. So equation 3 implies g of x will be equals to, send this f of x on the other side, will be getting minus of f of x. So we got the value of f of x over here, that is sine of x by 2. So therefore we have got the value of g of x is equals to minus sine x by 2. Substitute the values of f of x and g of x in equation number 1. Therefore, we'll be getting the value of z to be equals to f of x. You have f of x is sine of x by x into e power of y. Then g of x value is minus sine of x by 2 e power of minus of y. Sine x common outside. So suppose if I take sine x common and you can see 2 is common there, I'll just take 2 as the LCM. It is a common LCM. So you'll be left out only with the numerator e power of y minus of, here you have e power of minus of y. So it is sine of x into, because it is minus sign over here, you'll be getting sine h, the variable is y. So you're right. So the final solution will be z is equals to sine x into sine h y. So one more similar problem. Solve dou square z by dou x square plus 3 times of dou z by dou x minus 4 times of z is equals to 0. Solve this one subject to the condition that z is equals to 1 and dou z by dou x is equals to y when x is equals to 0. So that's the equation you have. If you try to observe over here in this PDE, it contains only one independent variable x, right? Since it contains only one independent variable x, you can write this in the form of the ODE. So you can write down in the form of ODE, we have the differential equation as d square z by dx square plus 3 times of dz by dx minus 4 times of z is equals to 0. If you write in the form of the operator, it becomes d square plus 3 times of d minus 4 times of z is equals to 0. So this will be in the form of the operator where this d is nothing but d by dx, because here independent variable is x. So now the auxiliary equation will be m square plus 3m minus 4 is equals to 0. So this the roots are 1 comma minus 4. Your solution will be z is equals to this c1 e power of independent variable is x, so c1 e power of x plus c2 e power of minus 4 is there, it is minus of 4x. So now if you write down the solution of the PDE, then the value of z will be equals to, so you'll be replacing the c1 by the function of y, because here x is the variable, y is treated as a constant, therefore we'll be writing it as f of y into e power of x plus this will be g of y into e power of minus of 4x.
Let me take this equation as equation number 1. We have the initial condition for dou z by dou x. Therefore, let us try to differentiate 1 partially with respect to x. So we get dou z by dou x is equals to, keeping f of y as it is, differentiation of e power of x will be e power of x, plus keeping g of y as it is, differentiation of e power of minus 4x will be e power of minus of 4x, into differentiation of minus 4x will be minus of 4. So if we try to rewrite this one, this will be equals to f of y into e power of x. So this is plus into minus will be minus 4 times of g of y into e power of minus of 4x. Let me take this as equation number 2. So go back to the initial conditions. The initial conditions that are given the value of z is equals to 1 when the value of x is equals to 0. So if you use this in equation number 1, equation 1 will imply, so equation 1 z value is 1, so 1 is equals to f of y into e power of x value is 0 plus g of y into e power of x value is 0. 0 times of 4 will be 0, but we know the value of e power of 0 will be nothing but 1. So if I just try to plug in that e power of 0 as 1 here, we get the equation as 1 is equals to f of y plus g of y. Let me take this as equation number 3. Also given in the question, the value of dou z by dou x. The value of dou z by dou x is nothing but y when the value of x is equals to 0. So let us try to plug in this in equation number 2. So equation number 2 implies your dou z by dou x will be y is equals to f of y times of e power of x value is 0 minus 4 times of g of y into e power of x value will be 0. But since e power of 0 is 1, so we get the result as y is equals to f of y minus 4 times of g of y. Let me take this as equation number 4. So let us try to solve equation 3 and 4. Solving 3 and 4, equation number 3 and 4. So we get 1 is equals to f of y plus g of y. This is equation number 3. Equation number 4 will be y is equals to f of y minus 4 times of g of y. So just subtract these values. This will be minus sign. This is plus over here. This will be minus. This is minus over here. Put it as plus. So plus f of y and minus f of y will cancel out. You will be getting the value to be equals to 1 minus y is equals to. Here plus 4 plus 1 will be 5 times of g of y, or the value of the g of y will be equals to, so keeping this 1 minus y as it is, cross multiply this 5, it is divided by 5. So solving this 3 and 4 and subtracting, we got this result. So I'll just try to plug in this value of g of y in equation number 3. Substitute the value of g of y in equation number 3. So your equation number 3 will be equals to 1 is equals to f of y plus g of y. G of y value is 1 minus y by 5. We just send this 1 minus y on the left hand side, it becomes 1. Positive sign is there. When it comes on the left hand side, it becomes negative. 1 minus of y divided by 5. This will be equals to f of y, or the value of f of y will be equals to, so if we take the LCM as 5 over here, just cross multiply this 5 on the other side, it becomes 5 minus of, you have 1 minus of y. So this will be equals to 5, this is minus of 1, and minus of minus will become plus y divided by 5, which will be equals to 5 minus 1 will be 4 plus y divided by 5. So we have got the value of f of y. Let us try to plug in this value back in equation number 1. Substitute the values of f of y and g of y in equation number 1. So we get the value of z to be equals to, so the value of z that we have is f of y. F of y value is 4 plus y divided by 5 times of e power of x. G of y value that we have got is 1 minus of y divided by 5 times of e power of minus of 4x. Or if I try to rewrite this one, the value of z will be equals. So if I take 1 by 5 common here, so I'll be getting the value as 4 plus y into e power of x. Here also if I take 1 by 5 common, I'll be getting 1 minus y into e power of minus of 4x. That is the required solution. That's all I have for today. Thank you.